Coffee time is a cherished tradition in the Lebanese culture. However, delivering and serving coffee and other hot liquids can be dangerous, especially for the elderly and disabled. In fact, according to the Centers for Disease Control and Prevention, injuries due to hot beverage spills account for over 9,000 emergency room visits a year in the United States alone. Our coffee delivery robot aims to streamline the delivery and serving process of any payload.
For the transportation, we used the human following solution. Because the turtle bot was out of stock, we used a KUKA robot which uses the histogram of oriented gradient method. The basic idea behind this method is to capture the local texture information of an image by computing the distribution of gradient orientation in small regions of the image. To do this, the image is divided to small cells, and for each cell, the gradient orientation of each pixel is calculated. A histogram of the gradient orientation is constructed for each cell.
In order to test our autonomous serving application, we used Gazebo Edifice and ROS2 Galactic. Using SLAM G mapping, we are able to save the map of our room. And then using this pre-saved map, we can use nav2 packages in order to control our robot. Using a nav2 controller, we can set the goal position, and then the robot can plan its trajectory and control its trajectory from its idle position to its goal position.
Our assembly caters for low-cost ergonomics and sturdiness, and the height of our assembly makes it comfortable and accessible to guests. The assembly consists of two acrylic trays, each 5 mm thick. The top one is where the payload will be put, and the bottom one is for the camera and the LiDAR. The trays are connected by 39.5 cm iron rods, and the trays are supported by 8 supports, 4 on each side, which are glued by Araldite for maximum stability. And the total mass of our assembly is 5.5 kilograms, which makes it lightweight and easily transportable.
So we conducted a finite element stress analysis on our design and received as a result a high safety factor. Furthermore, we need to check if slushing will occur. To do so, we did a vibration analysis on ANSYS. We also did a MATLAB simulation to get the displacement of the liquid inside the cup. And we finally also measured the accelerations on our actual robot. All of the tests showed that no slushing will occur and we can safely deliver any liquid with no slushing or spilling.
In conclusion, even though we were not able to combine all 3 of our subsystems into one physical robot, we were able to develop a successful human following application, an autonomous serving simulation, and a tested manufactured design.